In this lesson, we'll be looking at quadratic graphs. I'm using the new General Mathematics SS3. All my questions will be taken from that place. And the first question I have here is draw the graph of y equal to x squared plus 3x minus 4 for values of x from -5 to +2. Find a y when x is equal to 1.5, y when x is equal to -2.5, and x when y is equal to 4. Then the least value of x squared plus 3x minus 4, and the value of x for which y is the least. Now to solve a quadratic equation by graph, or to draw the graph of quadratic equation, the first thing we need to do is to prepare the table of values based on the value of x given to us here. We have a range of value of x given here. So the equation is y equal to x squared plus 3x minus 4. We'll prepare the table of value for x, which is -5. After -5 should come -4, -3, -2, -1, 0, 1, and 2, since the value of x is from -5 to 2. So the next value in the equation is x squared. So x squared will be the square of this, that is -5 times -5, which is 25. The square of this -4 times -4, which is 16. The square of this, that is -3 times -3, which is 9. This one will be 4, 1, 0, 1, and 4. 2 times 2, 4. And the next value is 3x, like 3 times x. 3 times -5 is -15. 3 times -4 is -12. 3 times -9 is 3 times -3 rather is -9. 3 times -2 is -6. 3 times -1 is -3. 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. The next term in the equation is a constant term, which is -4. It's a constant, so we just put it all through. -4, -4, -4 down to the end. And finally, we look for the corresponding value of y for each value of x. So when x is equal to -5, when x is equal to -5, what is y? Y is equal to, you solve this by substituting the value of x into the equation. So y will be -5 squared. What is the equation? Let me write the equation here so I have easy access. Okay, it's still here. -5 squared plus 3 times -5 minus 4. -5 squared is 25. Then plus times minus is minus. 3 times 5 is 15 minus 4, which is 25 minus 19. That is minus 15 minus 4 is minus 19. And 25 minus 19 is 6. 6. When x is equal to -4, which is the next value of x, y will be -4 squared plus 3 times -4 minus 4. -4 squared is 16. 16 plus times minus is minus. It will be 16 minus 12 minus 4. Minus 12 minus 4 is minus 16. 16 minus 16 is 0. Then y is equal to 0 when s is equal to minus 3. The next value of x, y will be minus 3 square plus 3 times minus 3 minus 4. Minus 3 square is 9. Minus times plus is minus 3 times 3 is 9. Then minus 4. 9 minus 9 is 0. So our answer is minus 4. When x is equal to minus 2, y will be minus 2 square plus 3 times minus 2 minus 4, which is minus 2 square is 4. Then 3 times minus 2 is minus 6 minus 4. Minus 6 minus 4 is minus 10. 4 minus 10 is minus 6. When s is equal to minus 1, y will be minus 1 squared plus 3 times minus 1 minus 4. Minus 1 squared is 1. Minus times plus is minus 3 times that. Then minus 4. 1 minus 3 minus 4 is minus 7. 1 minus 7 is minus 6. And when s is equal to, what is the next value? S is equal to 0, y will be, if I put 0 here, this is 0, 0, so y will be minus 4, minus 4. When s is equal to 1, y will be 1 square plus 3 times 1, which is 3, minus 4. 1 square is 1, 1 plus 3 is 4. 4 minus 4 is 0. Finally, when x is equal to 2, y will be 2 square plus 3 times 2 minus 4. 2 square is 4. 3 times 2 is 6 minus 4. 4 plus 6 10. 10 minus 4, 6. Okay, now that we know the values of x and y, we can plot the graph. The values of s ranges from negative 5 to positive 2. We're looking at this table, we have more of negative on the x-axis than positive. So when ruling a line, I'm going to leave more spaces to the negative part of the axis. So I have up to 5 there. So let's assume this is my 0, then negative 1, negative 2, negative 3, negative 4, negative 5. Okay, so that will be enough. That is the y-axis. Let's get the x-axis. Okay, so here is my graph sheet with the x and y axis marked. So now the next thing is to choose a scale for this graph. And in choosing scale, our choice of scale will determine the values we have, rather will determine the choice of scale we use. If we look at the x-axis, the values on the x-axis, I have more of negative than positive. And that is why I draw my graph, the lines. You can see how I leave more space towards the negative part of the graph down to the positive part, because on the x-axis, there are more of negative value. I have up to negative 5, but positive, I have just 2. There is 2 lines enough to represent that, which is here, 1 and 2. Then to the negative, I have more, which is up to 5. That is why I leave more space to the negative axis. Then looking at the values of y, I have positive 6 and negative 6. This one, they are kind of evenly distributed. So, but looking at this, I don't have up to 1, 2, 3, 4, 5. The highest I have there is 5. But here, let's check 1, 2, 3, 4, 5. Also 5. So the scale of 2 centimeter rather to 1 unit will not work here along the y-axis. However, it will work along the x-axis. So on the x-axis, I'm going to use a scale of 2 centimeter to 1 unit. 1 unit on x-axis. But on y-axis, I will use 2 centimeter to 2 units, meaning 1 centimeter to 1 unit in this case. On y-axis. Remember the standard wire graph, the distance between one big line and another big line, I mean this bold line, the distance between them is 2 centimeter. So if I say 2 centimeter to 1 unit, what that means is if this is my 0, which is the origin, here will be 1 and here will be 2. Let me remove that x that I wrote there. This will be my 2. This will be my negative 1, negative 2, negative 3, negative 4, and negative 5. But on the y-axis, I'm using 2 centimeter to 2 units, meaning here will be 2, here will be, let me not write it on that point, let me just write it close to the line. This is 2, this is 4, this is 6, and this is 8. This will be negative 2, negative 4, negative 6, negative 8. Okay, I think that is enough. The highest value we have there is negative 6. So now we can plot in the point. When s is negative 5, y is 6. Negative 5 is right here, so we trace it to y-axis until we get to 6, which is this point here. We'll put a point there. Then when x is negative 4, y is 0. This is negative 4 right here. Y is 0 at that point. Y is 0 is the line itself. Look at this point is 0. And this line is x-axis. Okay, so y, when x is, or what is it called? When s is negative 4, y is 0. This is this big line here, which is the x line. This is 0 for y. Because 0, 1, 2, 3, 4, and so it goes like that. Then when x is negative 4 and negative 3, y is negative 4. This is negative 3 for x. Then we trace it to y-axis negative 4, which is this point. When x is negative 2, y is negative 6. This is negative 2 for x. Trace it to y, negative 6. Then when x is negative 1, y is also negative 6. This is negative 1, trace it to negative 6, which is this point right here. When s is 0, y is negative 4. This is s is 0, y is negative 4. This is negative 4 for y. When s is 1, y is 0. This is y is 0 for x1. Then finally, when s is 2, y is 6. This is 2, y is 6. Okay, after plotting all the points, we now use a smooth curve to join all the points. Like we used to do when we were in school, we normally make use of a very soft broomstick, then curve it in a way that all the points will be joined with a smooth curve. But since this is a digital graph I'm using here, there's no way I can do that So let me see if I can use a freehand to join all these points together. This is not going to be perfect, but you get the idea. I'm trying. So this is the curve of this quadratic equation. Okay, now the question says, find y when x is 1.5. When s is 1.5, this is 1 here. 1.5 is the middle. So how can we find y? We trace it until we get to the curve. In your case, you may place a ruler so you get accurate result. Trace it until you touch the curve. Touch it. Okay, I touch it here. Then I trace that to y-axis. This is about 2.8 or so. It's not up to 3. 3 is right here. So when x is equal to 1.5, y is equal to 2.8. Notice that I trace it up. Why didn't I trace it down? If I trace it down, there's no way I can touch the curve. Look at it. I can't touch the curve down. So I have to look at, okay, where am I going to trace this thing to in order to touch the curve? So it's only up we can go to touch the curve. So that point where we touch the curve, we'll trace it to y-axis. That will give us the value of y at that point. We're using a real graph book and you drew it on using a smooth curve like I said earlier. You will get accurate results. This is just a rough work I'm doing here. Then the B part says find y when s is equal to negative 2.5. Negative 2.5, so this is 2, negative 2.5 should be the middle here. So, and we have to find y at that point. So, in this case, now I'm going to trace it down, not up. If I trace up, there's no way I can touch the curve. So, I will come down in this case. Here's my 2.5 somewhere here. Now, please trace it down. When tracing, you will make sure you use a ruler so the line will be perfect. I trace it until I touch the curve. To that point where I touch the curve, I'll then trace it to y-axis. Something like that. Like that. So about 5 or so. When x is 2.5, negative 2.5 rather, y is equal to 5. Negative 5, not 5. So the value is right here, negative 5. Find x when y is equal to 4. Y equal to 4. Here is y equal to 4. So in this case, we are going to trace to both sides. We have two values of x here. This is 4. I will trace here until I touch the curve. I touch it here. Then I will trace it down to x-axis. Trace it down. That is about 1.8 or so. When let's trace to the other side. Let me write it on this 1.8. Then I'll trace also to this side until I touch it. I touch the curve here. I trace it down. That is about negative 4.5 or so. 4.5. Negative 4.5. So let's write that down. When y is equal to 4, s is equal to negative 4.5 or 1.8. That is it. And finally, not finally yet, the least value of s squared plus 3x minus 4. The least value is the turning point. And the turning point occurs at this point, which is negative 6. So the least value is around y equal to -6. A bit lower than -6 anyway, because the curve, if you have a perfect curve, it's supposed to come down a little. Let's say 6.2, -6.2. Yes, so -6.2. So at which value of x does that occur? That is the last question. So the value of x for which y is least. So where do I have that -6.2? I will locate the place and trace it to y-axis, which is -1.4. So -1.4. So s is equal to -1.4 at that least value of y. So that is how to plot the graph of quadratic equation. Example 6, we have on the same axis, draw the graph of y equal to s squared minus 8s plus 5 and y equal to 2x minus 3. For values of x from -1 to +10, hence find the solution of s squared minus 8s plus 5 equal to 2x minus 3. So let's prepare a table of value for this quadratic equation first. So my x starts from -1 to +10. So -1, the next one should be 0, the next one should be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So with this, here I'm going to prepare, I only need x and y to save our time. I'm not going to put the value of s squared and -8x, all of that. So let's go on to y right away. When x is -1, by putting -1 there, that is, y becomes -1 squared is 1, minus 8 times -1 plus 5, which is 1 plus 8 plus 5. 1 plus 8 is 9, 9 plus 5 is 14. So here we have 14. When x is 0, this will be 0, this will be 0, y will be 5. When s is 1, we'll have 1 minus 8 plus 5 will be minus 8 plus 6, which is minus 2. When s is 2, that is 2 squared is 4, minus 8 times 2, 4 minus 16 plus 5. 4 plus 5 is 9, 9 minus 16, that is minus 7. Finally, when s is 10, 10 squared is 100, minus 8 times 10 is 80, plus 5, which will be 25. Now, for the second equation, which is y equal to 2x minus 3, we need only 2 points to plot that. How can we get those 2 points? We use intercept. If y is equal to 2x minus 3, to find y-intercept, we put s to be 0. If s is 0, the whole of this will be 0, so that y will be -3. Hence, y-intercept is 0 for x, then -3 for y. But we'll set x to be 0 then. To find s-intercept, we put y to be 0. If I set y to be 0, that means 0 is equal to 2x minus 3. Taking this minus to the other side, minus 3 to the other side to be plus 3 equal to 2x. Divide both sides by 2. So x is equal to 1.5 or 1.5. In this we can plot the graph. So before we plot this graph, let's look at the values on x axis. I have up to plus 10. I have only one negative. So I will leave more space to the positive side of the axis. And is my y-axis there. Let's draw the x-axis. For the x-axis, I have more positive also. I have up to positive 25. I will leave more space to the positive side. So let's choose a scale based on the values we have. Because I have so much of positive, so much of value on the y-axis, let's say if we can use 2 centimeter to 5 units. So if here is 5, here will be 10, here will be 15, 20, and 25. So let's do that. 5 here, 10 here, 15, 20, and 25. Here will be negative 5, negative 10, and negative 15. For the x-axis, I have from negative 1 to 10. Let's see if we can use 2 centimeters to 2 units. If I'm using 2 centimeters to 2 units, here will be 2, 4, 6, 8, and 10. That is enough. 2, 4, 6, 8, and 10. This will be negative 2 and negative 4. And let's put in the values. When x is negative 1, y is 14. Negative 1. If here is 2, negative 1 should be in the middle. And what is y at that point? Y is 14. Here is 15. 14 should be close to 15. 14 should be on this line here. This line. Then when x is 0, y is 5. When x is 0, y is 5. Right here. When s is 1, y is negative 2. 1 is right here, and s is negative 2. If here is 5, negative 2 should be somewhere here. No, it's here. This is the common here. Then when x is 3, no, when s is 2 rather, y is 7. Here is 2. This is 5, 6, and 7 right here. When x is 3, y is negative 10. 3 should be in between 4 and 2 and 4. Then y is negative 10. When x is 4, y is negative 11. This is 4 here. Negative 11 is right here. And when x is 5, y is negative 10. 5 is right here. And negative 10 is right here. When x is 6, y is negative 7. Here is 6. Negative 7 is right here. When s is 7, y is negative 2. 7 is right here, negative 2. is right here. When x is 8, y is 5. 8 and 5. When x is 9, y is 14. 9 and 14. 14 is right here. Then finally, when s is 10, y is 25. 25 is right here. And we join these points with a curve starting here. Let me see how perfect I could do these and these. Okay, I was very close to it. Though not perfect. So in your own case, you can use a smooth curve, and you can get smooth curve with the help of a broomstick, a soft one that you can bend to follow this point. That is that for the quadratic equation. Now for the linear equation, we need only 2 points to get to plot that, and the x-intercept is, I did not write it, x-intercept, well, that is 1.5 and 0, 1.5. We locate 1.5. This is 1. 1.5 should be somewhere here. Let me use a black ruler, a black pen. 1.5 should be right here. Then what about the y-intercept? The y-intercept is negative 3. 0 and negative 3. Negative 3, this is negative 5. So negative 3 should be somewhere here. Okay, now with a ruler, we'll connect those 2 points together. Okay, let me complete this quadratic curve because the point of intersection of these 2 lines will give us the solution to this. So let me try and get a perfect curve here. This is supposed to come like this. Like this. Oh, something close to this. So this point of intersection and this point of intersection, you will trace it to x-axis. Trace this one too down to x-axis. That will give us the solution to this equation. So x is equal to, based on what I have here, this is around 1, x equal to 1 or 1 point something. This is a rough work I'm doing just to give you an idea. Why this side, that is 8 point, let's say 8.4 or so, something like that. Now also trace those points to y-axis. If I trace this to y-axis, this is negative, let's say 1.2. And we also trace the other side to y-axis. Let me use a black pen then. If I trace this to y-axis, something like this. This is 15 point, let's say 15.2. Or 15.2, something close to that. So these are the values for the solution for this equation. We have more example here. Example 7. It says draw the graph of y equal to x squared minus 2x minus 4. Use this graph to solve the equation x squared minus 2x minus 4 equal to 0. Find the gradient of the curve at the points x equal to 2 and x equal to -1. So in this case, since they did not give us the value of x, no range of value of x, let's just choose any range of value. I'm going to use from -2 to +4 for the range of values of x. So that if my graph is x squared minus 2x minus 1, minus 4 rather, preparing my table of value, I'll have x, it is starting from -2, -1, 0, 1, 2, 3, and 4. So x squared will be 4, that is the square of this, 1, 0, 1, 4, 9, and 16. -2x will be -2 times -2 is 4, -2 times -1 is 2, this will be 0, this will be -2, -4, and multiplying this by this, -6, -8. And this is a constant term, so it's going to be -4, -4, -4, -4, -4, and -4. And finally, we need to get the value of x, of y rather. When x is -2, when x is -2, y will be -2 squared minus 2 times -2 minus 4. -2 squared is 4. And negative times negative is positive, so +4. -4 minus, so I have 4 right there. Then when x is -1, y will be -1 squared minus 2 times -1 minus 4, which is 1. Minus times minus is plus, and minus 4. 1 plus 2 is 3. 3 minus 4 is -1. -1 right there. When s is 0, is 0 right here. If I put in 0 here, everything will be 0. I'll be left with -4. When s is equal to 1, that is this place, 1, that will be 1 minus 2 minus 4, which is 1 minus 6, which is -5, -5. When s is equal to 2, y will be 2 squared, which is 4. I'm putting it right here. Minus 2 times 2 again, 4. Then minus 4. 4 minus 4 gone. Then I'm left with only -4. When x is equal to 2, okay, that is 2 adjustment. When s is 3, 3 squared here is 9. Then 2 times 3 is 6. And minus this 4. -4 minus 6 minus 4 is -10. 9 minus 10 is -1. When s is equal to 4, 4 here is 16. 2 times 4 is 8. And minus this 4. -8 minus 4 is -12. 16 minus 12 is 4. Okay. I will know the value of this. Can I plot the graph? So here is a graph with x and y axis mark. This is x axis. Write it well. And this is y axis. So now let's choose our scale based on the values we have. On the x-axis, I have -2 to +4. I think a scale of 2 centimeters to 1 unit will be okay here. The highest value of X there is positive 4. While the highest is negative 2. That is why I leave more space to the positive side. So here will be 1, here will be 2, here will be 3, here will be 4, which is the highest value of X, then negative 1 and negative 2. On the y-axis, let's look at the value. The highest value here is negative 5, while the highest negative rather is negative 5. The highest positive is positive 4. So I leave more space to the negative since the negative are more. So I'll have negative 1 here, negative 2, negative 3, negative 4, and negative 5. Using a scale of 2 centimeters to 1 unit on both axes, this is 1, this is 2, this is 3, and the extreme end here is 4. With the graph marked, let's plot in the point. When x is negative 2, y is 4. Negative 2, y is 4. This extreme end here. Then when x is negative 1, y is negative 1 also. This is negative 1, and negative 1 is right here for y. And when x is 0, y is negative 4. This is 0 here. Negative 4, we'll trace it down, which is here. When x is 1, y is negative 5. 1 is right here. We'll trace it to negative 5, which is here. When x is 2, y is negative 4. 2 is here, negative 4. We'll trace it down, which is right here. When x is 3, y is negative 1. 3, negative 1 is right here. When s is 4, y is also 4. 4 to 4. So right here. Okay, we need to join all these points together. Let me zoom out so we can capture the point at once. Missed it again. Something like this, yeah? Now the question says find the gradient of the curve at the point s equal to 2. At the point x equal to 2, you mark here is a point, so you put a straight line with your ruler. Though this curve is not smooth enough, that doesn't mean it's smooth enough. We're supposed to be able to capture that point exactly. If s equal to 2, press it until you meet the curve, which is right here. Then place a ruler there and rule a straight line. Rule a straight line there. And we'll calculate the gradient of this. How can we do that? We'll drop a line here to form a triangle. Let me do that. Okay. Now gradient is increasing y over increasing x. So we'll trace these 2 points. Gradient here, let's call it m1 equal to y2 minus y1 over s2 minus s1. Our y2, our y1 is this, which is negative 4, then minus y, that will be negative 1.5 also, 1.5 over x1 and x2. This is s1 and this is s2. s2 is 4. 4 minus 2. So this will be negative 4 plus 1.5 all over 2, which is negative 3.5 over, supposed to be 2.5, not 3.5. Negative 2.5 over 2 is negative 1.25. That is for the gradient there. Then they say we should also get the gradient at x equal to negative 1. Again, where is negative 1? This point right there. Place a ruler there and draw a straight line. And pick some points there. Let me pick these 2 points. I think it will be better if I pick these points right here. Again, my gradient there will be, let's calculate it here. So this point here is 0, while this one here is negative 3. Then gradient there, which is y2 minus y1. y2 is 0, 0 minus y1 is minus 3 over x1 and x2. S1 is 0, S2 is 1.5 or so, minus 1.5 minus 0, that will be 3 over minus 1.5. That will be 3 divided by 1.5 is about 2, minus 2. That was a rough one anyway. That is how to calculate the gradient by that. It's a rough sketch. And the final example here. You say draw the graph of y equal to 2x squared plus 3x minus 6 for values of x from negative 4 to positive 2. So let's draw the table of value. Negative 4, negative 3, negative 2, negative 1, 0, 1, and 2. I have 2x squared and 3x and negative 6, which is a constant. Negative 4 squared, that is when I put negative 4 squared here, that is 16. 16 times 2 is 32. Then this one will be 9. 9 times 2 is 18. 4. 4 times 2 is 8. 1. 1 times 2 is 2. This will be 0, 2, and 4, and no, and 8. Then 3 times negative 4 is negative 12. 3 times negative 3 is negative 9. 3 times negative 2 is negative 6. 3 times negative 1 is negative 3. 0, 3, and 6. This is constant, negative 6, negative 6, negative 6, negative 6, negative 6. And let's find the value of y when x is equal to negative 4, putting it here, y will be 2 times negative 4 squared plus 3 times negative 4 minus 6. Negative 4 squared is 16. 16 times 2 is 32. Minus 12 minus 6, which is 32 minus 18. 32 minus 18. When s is equal to negative 3, y will be 2 times negative 3 squared plus 3 times negative 3 minus 6. Negative 3 squared is 9. 9 times this is 18. 18 minus 9 minus 6, which is 18 minus 15. 18 minus 15 is 3. When x is equal to minus 2, y will be 2 times minus 2 square plus 3 times minus 2 minus 6. Minus 2 square is 4. 4 times this is 8. Is minus 4. Minus 4. When s is equal to minus 1, y is equal to 2 times minus 1 square plus 3 times minus 1 minus 6. Minus 1 square is 1. 1 times this is 2. 2 minus 3 minus 6, which is 2 minus 9 minus 7. Minus 7. And when s equal to 0, y is equal to 2 times, the whole of this will be 0, 0, so y will be minus 6. Minus 6. And when x is equal to 1, y will be 2 times 1 square plus 3 times 1 minus 6, which is 5 minus 6. 5 minus 6 is minus 1. And when s is equal to finally 2, y equal to 2 times 2 square. Square is 4. 4 times this is 8. 8 plus 6 minus 6. 6 minus 6 is 0. I have 8 there. Okay, now that we know the values of x and y, we can plot the graph. And so here is our graph book. I've already put the scale. Based on the values we have, I have up to positive 14 here. So I have to use a scale of 2 centimeters to 4 units on the y-axis to accommodate that 14. But on the x-axis, I'm using a scale of 2 centimeters to 1 unit. So I have 1, 2, then negative 1, negative 2, negative 1, down to negative 5. And then let's put in the values. When x is negative 4, y is 14. Negative 4 is right here, so we trace it to 14. This is 12. 14 should be, excuse me, 14. Yeah, I think this is good enough. Then the question went on to see, where's the question? Use the graph to solve the equation 2x squared plus 3x minus 6 equal to 0. Remember, the curve we plot is for that curve. So how do we use it to solve the equation equal to 0? That is, when y is equal to 0. To get that, we'll trace where the curve meets x-axis. That will be the solution to that equation. This point and this point. So s equal to, since this my graph is just a rough sketch, the answer may not be accurate. So this is about 2 point, negative 2.7 or so, or this place is 1.2 or so. That is an approximate value. And the second part of the question says, okay, use the graph to solve the equation. We just did this. And the second is 2x plus 3x minus 3 equal to 0. Now we're going to compare this equation and this equation. We see that we have 2s here, we also 2s squared rather. We have 2s squared also here. We have 3s here, we have 3 here. So we are going to subtract the two equations and see the difference. So the first equation is 2s squared plus 3x minus 6, which is the graph we plotted. The other one is 2s squared plus 3s minus 6. We subtract, we have, oh, this is supposed to be minus 3. Minus 3. If we subtract these two equations, the difference will be minus 3. Meaning y is equal to minus 3 at that point. If y is equal to minus 3, we will look at the graph and draw a line at minus 3. Minus 3 should be somewhere here. Draw a line to touch the curve and find the value of x at that point. Draw a line to touch it here. Trace it here also. Let me use a ruler. So this, we'll place a ruler at minus 3 and then trace it to the curve with a dotted line. Oh, ruler is shifting. Okay. Now we read the value of x at that point by tracing it to x-axis. We also trace it to x-axis. So here I have about 0.8 or so. For the second equation, x is, let's read the negative first. Negative 2.4. It's not up to 5. 2.4 or 0.8 or 0.9 also. This is a rough work. We may not get a perfect answer. The C part of that question says, by drawing the line y equal to 2x plus 1 on the same axis, solve the equation 2x squared plus x minus 7 equal to 0. Okay, again, we are going to take the difference between this equation and this equation. So that if I have y equal to 2x squared plus 3x minus 6, and I subtract this equation from 2x plus 1. This minus this will give me x, and minus 6 minus 1 is minus 7. So you can see that this equation now becomes 2x squared plus x minus 7. So let's draw that curve of y equal to 2x plus y, 2x plus 1 rather. To do that, we need only 2 points. If I have that y equal to 2x plus 1, to find x intercept, we set y to 0. So if y is 0, I have 2s plus 1, meaning minus 1 is 2s. S will be minus half. And s intercept, therefore, will be minus half and 0. Now to find y intercept, we put s to be 0. If I put s to be 0 here, y will be 1. So that y intercept will be 0 and 1. With that 2 points, we'll be able to draw the curve. S is 0.5, negative 0.5 rather. Negative 0.5 is right here. 2.5 is writing y is 1, a positive 1 or so. Yes, positive 1. Let's assume it's somewhere here. So with these 2 points, you can draw the curve. Okay, so that is the line. Now, where the line meets the curve, we trace it to x axis. If I trace the down, y is 1.6 or so. Again, let's trace the other side. Here we are tracing up. Is negative 2.1 or so. So s equal to negative 2.1, or tracing this up down 1.6.